All right, let's dive into the world of quantum programming. Today, we're pitting two of the biggest players against each other, Google's Cirq and Amazon's Braket. It's going to be a quantum showdown.
So, when you think about programming a quantum computer, does one specific tool just pop into your head? If it does, you're definitely not alone. But the truth is, the landscape is way more diverse and, honestly, a lot more interesting. I mean, think about it this way. For the laptop or phone you're using right now, there's Python, Java, C++, a whole universe of languages, right? Each one is good for a different job. Well, the quantum world is building that same kind of ecosystem. It's got its own set of specialized toolkits, or SDKs, and knowing how to navigate them is becoming super important. First up in the ring, we've got Google's contender, Cirq. And you can really think of Cirq as the specialist's tool. It's been designed with a very, very specific job in mind.
What's so fascinating about Cirq is just how tightly it's woven into Google's own hardware. It's built from the ground up to work with their Sycamore processors. It basically speaks their native language. It also has this thing called moment-based circuits. You can imagine it like a musical score for your algorithm. It lets researchers control the precise timing of every single operation, deciding exactly what runs in parallel at each moment. And for stuff like quantum error correction research, that kind of timing control is absolutely crucial.
And in the other corner, we have Amazon Braket. Now, if Cirq is the finely tuned specialist, Braket is the versatile do-it-all generalist. It uses the sheer power of the Amazon Web Services cloud to offer a completely different approach. And this is where the difference between them becomes crystal clear. See, Braket isn't married to one type of hardware. It's more like a universal gateway on AWS. It gives you access to quantum computers from a bunch of different vendors. Think Rigetti, IonQ, plus a whole suite of powerful simulators. The keyword here is flexibility. You can write your code just once and then decide which backend you want to run it on, whether it's real hardware or a simulation, all inside that familiar, scalable AWS environment.
Okay, so we've met the contenders, but talking is one thing. How do they actually stack up in practice? To figure that out, we're going to make both of them perform the exact same task, building a Bell state. Let's see how they do it.
But wait, before we jump into the code, what in the world is a Bell state? Well, to put it simply, it's like the hello world of quantum circuits. It's one of the most basic ways to show off a truly bizarre quantum thing called entanglement. That's where two qubits get linked together, and the state of one instantly tells you the state of the other, no matter how far apart they are. Pretty wild, right?
Okay, code time. Let's look at this side by side. On the left, you've got Cirq. See how we first have to explicitly define our two qubits, Q0 and Q1? Then we build our circuit by feeding it a list of operations. Put a head amount gate on Q0, then a CNOT gate to link Q0 and Q1. Now look over at Braket on the right. It feels a lot more streamlined, doesn't it? It's a chained approach. You just start a circuit and then tack on the gates. .H0 for head amount on qubit 0, then .CNOT01 for the CNOT. They look different, but don't be fooled. They're both getting the exact same quantum job done. So we've seen the syntax, we've seen the different styles, but what does this all mean for you when you have to actually pick a tool for a project? Let's break down how you might make that choice. This table pretty much says it all. You know, if you're deep in the weeds of quantum research, and especially if you're working with Google's hardware, Cirq's precision and that moment-based control is a massive advantage. But if you need flexibility, if you want to scale up, and if you want to play with hardware from lots of different companies, Braket's cloud approach is a no-brainer. It really just comes down to what kind of problem you're trying to solve. So why does any of this matter to you? Well, here's the bottom line. The quantum field is moving incredibly fast. Sticking to just one platform is like a classical developer deciding they're only ever going to learn one programming language. It just doesn't work. Getting your hands dirty with different SDKs like Cirq and Braket makes you so much more adaptable and, frankly, more employable. It shows you get that quantum computing is a multi-vendor world, and you know how to pick the right tool for the job. And that is an incredibly valuable skill to have. So there you have it. The specialist went head-to-head with the versatile cloud platform. You've seen their core philosophies, you've seen their code. This whole quantum ecosystem is just buzzing with these powerful tools, and they're all just waiting for people like you to use them. So the only question I have left is, now that you've got these tools in your toolkit, what problem are you going to solve first?